7 miles beneath the surface of the Pacific Ocean, in the deepest place on Earth, something is beating. Not metaphorically, not poetically, literally beating. A rhythmic pulse echoing through the crushing darkness of the Mariana Trench, recorded by sensors that were never supposed to pick up anything like this. The sound repeats every few seconds, steady as a metronome, powerful as thunder. Scientists call it the Mariana Trench Heartbeat. And here's what makes it terrifying. No one can definitively explain what's causing it. Imagine standing at the edge of Mount Everest and looking down. Now imagine flipping that mountain upside down and dropping it into the ocean. It still wouldn't reach the bottom of the Mariana Trench. At its deepest point, the Challenger Deep, the ocean floor sits nearly 7 miles below the waves. The pressure there exceeds 8 tons per square inch, enough to crush a submarine like a tin can, enough to compress even water itself. This is a place where sunlight has never reached, where the weight of the entire ocean presses down with incomprehensible force, where temperatures hover just above freezing and yet life somehow persists. And in this alien realm, something is making noise. For decades, scientists believed the deep ocean was silent, a dead zone, but they were wrong. The abyss is alive with sound, whale songs that travel thousands of miles, the grinding of tectonic plates, the crack and groan of underwater earthquakes. But this sound is different. This sound has structure, pattern, intentionality. It pulses with mechanical precision, rising and falling in amplitude, broadcasting through the water like a signal. Some researchers hear in it the rhythm of a biological heartbeat. Others detect something more mechanical, more deliberate. And a growing number are asking a question that once would have seemed absurd. Could something down there be trying to communicate? But the truth is far stranger than anyone first imagined, because the Mariana Trench Heartbeat isn't just one phenomenon. It's part of a larger mystery that connects the deepest trenches, the movement of continents, and sounds that have been recorded across the world's oceans for over 50 years. Sounds we've dismissed, sounds we've ignored, sounds that are now impossible to explain away. To understand how we got here, we must go back to the beginning. Back to when humanity first dared to venture into the deep. The story of the Mariana Trench begins not with sound, but with depth. In 1875, the HMS Challenger, a British Royal Navy ship converted for scientific exploration, was conducting the first comprehensive survey of the ocean floor. Using weighted ropes, the crew measured a staggering depth of over 0 feet in the western Pacific. They had discovered the deepest known point on the planet, later named Challenger Deep in their honor. But measuring depth was one thing. Understanding what lay below was impossible with 19th century technology. For decades, the trench remained untouched. Then, in 1960, U.S. Navy Lieutenant Don Walsh and Swiss oceanographer Jacques Picard squeezed into a bathyscaphe called Trieste and descended into the abyss. Their dive took nearly 5 hours. Through the tiny porthole, they witnessed something remarkable. Even at 0 feet below the surface, life existed. A flatfish and shrimp-like creatures moved through the sediment. The deep ocean wasn't sterile after all. It was thriving. But the Trieste carried no sophisticated listening equipment. The sounds of the deep remained unknown. Meanwhile, across the world, Cold War paranoia was driving innovation in underwater acoustics. The U.S. Navy deployed a network of underwater microphones called hydrophones to detect Soviet submarines. This system, known as SOSUS, the sound surveillance system, was never intended for science. But in the 1960s and 70s, Navy operators began picking up strange sounds. Low-frequency moans, high-pitched whistles, mysterious booms that had no obvious source. Most were classified and forgotten. But some leaked out, capturing the imagination of marine biologists who realized that the ocean wasn't just full of life, it was full of voices. By the 1960s, declassified SOSUS data revealed a catalog of bizarre underwater sounds. The bloop, recorded in 1997, was an ultra-low-frequency pulse detected by sensors thousands of miles apart, loud enough to be biological, but far larger than any known creature. The upsweep, a seasonal sound that rises in frequency, has been recorded continuously since 1991 with no confirmed source. Slowly, scientists began to understand that the ocean floor itself was acoustically active, producing sounds through geological processes, volcanic activity, and the movement of ice. But nothing prepared them for what would be discovered in the Mariana Trench. In 2016, a team from the National Oceanic and Atmospheric Administration deployed a titanium-encased hydrophone into the Challenger Deep. The device, designed to withstand pressures that would obliterate conventional equipment, recorded continuously for 3 weeks. What it captured stunned researchers. Among the expected sounds of earthquakes, ship propellers, and baleen whale calls, was something else entirely: a rhythmic, repeating pulse, low frequency, powerful, consistent, occurring approximately every 10 to 15 seconds. The sound appeared strongest near the trench floor and seemed to emanate from the subduction zone itself, where the Pacific Plate slides, beneath the Mariana Plate. The initial hypothesis was straightforward. This was a geological phenomenon. Perhaps magma moving through cracks in the seafloor. Perhaps the friction of tectonic plates grinding together. But the regularity troubled scientists. Geological processes are chaotic. Earthquakes rumble and fade. Volcanic vents hiss and bubble unpredictably. This sound was different. It had cadence, rhythm, almost like a heartbeat. This sound, in Biren, and it didn't stop. Analysis of follow-up recordings in 2018, 2020 and 2023 confirmed the sound was still there, still pulsing, still maintaining its airy consistency. Something 7 miles down was making this noise, and it had been doing so for years. Possibly decades, possibly longer. The first chapter of this mystery centers on biology. Could the Mariana Trench heartbeat be produced by a living organism? The idea isn't as far-fetched as it sounds. The deep ocean is home to creatures that defy imagination. In 2021, Japanese researchers, using remote-operated vehicles, discovered snailfish thriving at depths of over 0 feet. These translucent, gelatinous animals have evolved bodies that resist crushing pressure, with bones that are barely calcified and cells packed with organic molecules that prevent compression. If life can exist at those depths, could something even larger be lurking deeper? Whales are the ocean's great communicators, producing songs that travel across entire ocean basins. Blue whales generate sounds at around 20 Hz, below the threshold of human hearing, powerful enough to be detected hundreds of miles away. But the Mariana Trench heartbeat operates at even lower frequencies, between 5 and 15 Hz, and originates from a location no whale could survive. The pressure at Challenger Deep would collapse the lungs of any mammal instantly. Steel. Some researchers have speculated about the possibility of an undiscovered deep-sea species, perhaps something resembling the giant squid, or an unknown cephalopod, capable of producing sound through unique biological mechanisms. In 2022, a study published in Deep Sea Research analyzed the acoustic signature of the heartbeat and compared it to known biological sounds. The conclusion was unsettling. While the frequency range overlapped with certain whale calls, the pattern itself was unlike anything produced by any known marine animal. Biological sounds typically vary. A whale song shifts in pitch and rhythm. A dolphin's clicks change based on context. The Mariana Trench heartbeat does not. It repeats with machine-like precision, suggesting either an organism with an extraordinarily rigid communication pattern, or something that isn't biological at all. The deeper researchers looked, the stranger it became. But if not biology, then what? The second chapter turns to geology, and here the mystery deepens further. The Mariana Trench sits atop one of Earth's most active subduction zones, where the Pacific Plate dives beneath the Mariana Plate at a rate of about 2 inches per year. This collision generates enormous pressure, creating earthquakes, underwater volcanoes, and hydrothermal vents. Could the heartbeat be the sound of the Earth itself? groaning under the strain of continental drift. Many scientists believe this is the most likely explanation, but the details don't quite fit. In 2023, researchers from Oregon State University deployed a network of ocean-bottom seismometers near the trench. These instruments detect seismic activity, the rumble of earthquakes and the shift of rock deep beneath the seafloor. What they found was unexpected. The Mariana Trench Heartbeat didn't correlate with seismic events. It occurred independently of earthquakes, independent of measurable tectonic movement. The sound appeared to originate from a specific location within the trench, roughly 500 feet below the surface, but seismometers detected no corresponding vibrations in the rock. Somehow, the sound was traveling through the water without shaking the ground. One hypothesis involves fluid dynamics within the subduction zone. As the Pacific plate descends, it carries water trapped in sediments and minerals. Under extreme pressure and heat, this water is released, creating superheated plumes that rise through cracks in the overlying plate. These hydrothermal fluids can generate sound as they escape, much like a kettle whistling on a stove. In 2024, a French oceanographic team used advanced sonar mapping to identify a cluster of hydrothermal vents near the suspected origin point of the heartbeat. The timing seemed promising. But when they deployed submersibles to investigate, they found the vents were active, but irregular, venting sporadically, nothing like the steady pulse recorded by hydrophones. The geological explanation, while plausible, couldn't account for the regularity. And then came a discovery that changed everything. In early 2025, a joint expedition, led by scientists from the Woods Hole Oceanographic Institution and Japan's JAMSTEC, deployed an autonomous underwater vehicle equipped with magnetometers, chemical sensors, and high-definition cameras. The mission, destined to the source of the heartbeat and observe it directly. For 11 hours, the AUV navigated the darkness, its lights cutting through swarms of translucent amphipods and jellyfish that drifted like ghosts. At 34 feet, it reached the trench floor, and there, embedded in the sediment, it found something no one expected. Not a creature, not a vent, but a formation. A series of perfectly circular depressions in the mud, each about 15 feet across, arranged in a geometric pattern. The formations were ancient, covered in layers of sediment that suggested they had been there for centuries, possibly millennia. But here's what made them extraordinary. They were resonating. The AUV's sensors detected vibrations emanating from the depressions, synchronized with the heartbeat. Somehow, these geological structures were functioning like organ pipes, channeling the movement of water and sediment to produce sound. But how? And more disturbingly, why were they arranged in such an orderly pattern? The third chapter of this mystery ventures into the speculative, and it's here that science bumps up against the limits of current understanding. Some researchers now propose that the Mariana Trench Heartbeat is not random, but the result of a feedback loop between geology, biology, and fluid dynamics. The circular depressions may have formed naturally through the settling of heavy metallic sediments, creating pockets of denser material. Over millions of years, tidal forces and deep ocean currents shaped these pockets into resonant chambers. When water flows over them, driven by the slow churning of deep-sea circulation, they vibrate, producing sound. But that doesn't explain the precision. Feedback loops in nature are usually messy. River currents eddy and swirl. Wind produces turbulent gusts. Yet the heartbeat maintains nearly perfect regularity. In 2025, a controversial paper, published by a team at MIT, suggested an alternative: self-organized criticality. This is a phenomenon where complex systems spontaneously arrange themselves into highly ordered states. Sand dunes form regular patterns. Snowflakes grow into symmetrical crystals. Could the deep ocean, under the right conditions, create acoustic structures that self-regulate, producing rhythmic sound as a byproduct of natural organization? The idea is elegant but unproven, and it raises an even more unsettling question. If the ocean can self-organize to produce sound, what else might it be capable of? A fringe theory, dismissed by most mainstream scientists, but gaining attention in certain circles, suggests the formations are not natural at all. Proponents point to the geometric arrangement, the precision of the resonance, and the fact that similar circular structures have been found in other deep ocean trenches. Could they be remnants of some ancient, unknown process? Not alien, they're quick to clarify, but perhaps evidence of past tectonic activity we don't yet understand, or biological engineering by deep-sea organisms we've never encountered. The hypothesis is speculative, bordering on science fiction, but it highlights how little we truly know about the deepest parts of our planet. After all, humans have better maps of Mars than we do of the ocean floor. This changes everything we thought we understood about the deep ocean. For centuries, we've treated the abyss as a passive void, a place where things fall and settle, where pressure and darkness create a lifeless wasteland. But the Mariana Trench Heartbeat proves that the deep is active, dynamic, and capable of producing phenomena we can't yet explain. It suggests that the boundary between geology and biology, between the living and the non-living, may be more blurred than we realized. And it forces us to confront an uncomfortable truth. Earth still has secrets, big ones. The implications extend beyond curiosity. Understanding acoustic phenomena in the deep ocean has practical applications. Submarine navigation relies on sound. Climate models depend on understanding deep ocean circulation, which is influenced by temperature, salinity, and pressure. If geological structures can produce powerful, low-frequency sounds, they could interfere with sonar systems, create false readings, or mask the presence of other acoustic sources. Military and commercial interests are already taking note. But the greatest mystery still remains. What created those formations? Why are they arranged so precisely? And if the heartbeat is a natural phenomenon, why does it feel like something more? Scientists are racing to answer these questions. In late 2025, plans are underway for a crewed submersible dive to the source of the heartbeat, the first human visit to that specific location since the Trieste's historic descent. The mission will carry sediment cores to analyze the composition of the formations, acoustic sensors to map the sound in 3 dimensions, and cameras to document everything in unprecedented detail. Researchers hope to determine once and for all whether the structures are geological, biological, or something entirely unexpected. But deep-sea exploration is slow, expensive, and dangerous. Answers may take years. Meanwhile, the heartbeat continues, steady, relentless, pulsing through the darkness like the rhythm of some vast, hidden machinery. Every 10 to 15 seconds, it echoes through the Mariana Trench, a sound that shouldn't exist, a reminder that even in the 21st century, with all our technology and knowledge, there are still places on Earth we do not understand. Places that resist explanation. Places that keep their secrets buried under 7 miles of water and the crushing weight of an entire ocean. And perhaps that's the most profound lesson of the Mariana Trench Heartbeat. Not what it tells us about the deep, but what it reveals about ourselves. We are a species that has walked on the moon, sent probes to the edge of the solar system, and peered back to the birth of the universe. Yet we remain strangers to our own planet. 70% of Earth is covered by ocean, and we've explored less than 5% of it. The deep remains largely unknown, a frontier as alien and inaccessible as outer space. The heartbeat is a reminder that discovery isn't finished, that mystery still exists, that there are questions left to answer and wonders left to find. So, what happens next? Expeditions will continue. Data will be analyzed. Theories will be tested, refined, and sometimes discarded. The scientific process grinds forward, patient and methodical. But the heartbeat doesn't wait for us to catch up. It will keep pulsing, indifferent to our curiosity, long after this documentary ends, long after the sensors are retrieved, long after humanity has moved on to the next mystery. Because the ocean doesn't care about our timelines or our need for answers. It operates on its own scale, vast and ancient and utterly unconcerned with the brief flicker of human civilization. And maybe that's why the Mariana Trench Heartbeat captivates us so deeply. It's not just a scientific puzzle. It's a reminder of humility, a reminder that we are small, that the earth is old, that beneath the waves, in the crushing darkness, there are things that exist beyond our understanding, things that have been there for eons, things that will be there long after we're gone. The heartbeat is the sound of the planet itself, breathing, shifting, alive in ways we're only beginning to comprehend. It's the sound of mystery, the sound of the unknown, the sound that shouldn't exist, but does. Because in the end, the deepest oceans hold more than water and pressure and ancient rock. They hold the last great secrets of Earth. And the Mariana Trench Heartbeat is just one of them. One rhythm in a symphony we've only started to hear. One pulse in the vast, unknowable heart of the deep. And somewhere, 7 miles down, in the darkness where no light has ever reached, it continues, steady, eternal, waiting for us to understand. Or perhaps simply waiting, because the universe always has another secret waiting. And so does the ocean.